Right, so this chapter is about vectors, the last chapter of the pure maths. Again, not much different to the year 12 vectors, where you just learn about 3D compared to 2D. I would say that sort of the main issue or main question in vectors, question usually asked in a pure math paper is about the geometric problems, where you ask to prove, where you ask to show they're parallel, where you ask to show they form a trapezium, etc. Okay, so I would say that was probably the key bit about vectors. Right, so in here we learn about 3D vectors and distance. In your paper, you should have space. If you've got a bit of space, you can make a nice table. If you don't want to, well, yeah, you can see me do it first before you know how much space to use it. You can use the full space of the full width and full length of the space. So you've got in here coordinates. You've got 2D and 3D. So we compare 2D and 3D. So first of all, coordinates. In 2D, the coordinates, needless for me to say, x, y. For 3D, alphabetically, x, y, and then z. Or z. Next, distance. So we've learned about how to find distance between 2 points in 2D. Does anyone remember the formula? The square root of, yep, so it could be x1 minus x2 squared plus y1 minus y2 squared. Well, for 3D, it's all the same with the set. We add a bit with the set in there as well. So the distance equal to the square root of x1 minus x2 squared plus y1 minus y2 squared plus z1 minus z2 squared. And last but not least, we look at the vector form, the vector form. In 2D, we use xi plus yj, or we can write as a column vector, which is quite useful for calculation, because then we can compare the top row with the equate top row and equate the bottom row. We've done this a lot in mechanics, especially last part, chapter 8, when you need vectors to do any mechanics, the Ruvart equations. Vector form for 3D, x, y, and z, I, j, and k. So xi plus yj plus zk. In column vector, will be the same, x, y, z. Okay, so nothing new really. So just a nice table for you to see a difference of them. Do you have to remember anything? I don't think so, because if you have done if you know the 2D part, the 3D part comes up quite natural to you. Okay, right. So we're going to move on. Next. Example number 1. Find the distance between the points A and B. Give your answers into one decimal place. So distance equal to square root of x1 minus x2 squared. So 1 minus 8 squared plus 3 minus 6 squared plus 4 minus 5. So 4 plus 5. Let me write minus in here. In a calculator, you can do minus in a calculator. It will do them plus for you. So anyway, put the whole thing in a calculator, and I'm just 11.8. No units. Distance. That's this 11.8. Okay, fairly straightforward. The next example, let me try it. It should be okay to try it. Yeah, I'll give you 2 minutes. If you are doing with the video, you can pause the video, have a go at the question. Okay, for example number 2. So here's the answer. You make them equal each other, and then you just get a square root, get a square. There are different ways you can do it. You can expand a bracket, find a k, get a quadratic, etc. As long as you get k equals 1 or 5. From the question, you can tell, find the possible values of k. You know there are more than 1. Okay, so look through the hints similarly in the exam as well. Right, next one. Example number 3. Consider a equals 1, 5, minus 2, and b is 0, minus 3, 7. Find the position vectors of A and B in IJK notation. We mentioned about position vectors in mechanics before. How do you write position vector as a vector in terms of the letters? Can you remember? OA. Yeah, position vector means you start measuring from O. So position vector of A essentially means OA. OA is the same as a coordinates of A, so which is 1i plus 5j minus 2k. You don't have to write a 1, of course. I plus 5k minus 2k. So it comes from the coordinates of A. So position vector is the same as the coordinates, but in a vector form. OB, or 0i minus 3j plus 7k. Part B, find a vector AB as a column vector. To find a vector AB, the shortcut is to do B minus A. Do the second letter, take away the first letter. Well, why, if you wonder? So AB, I can rewrite AB as AO plus OB, which is the same as negative OA plus OB, which is the same as OB minus OA. Well, ignore it. We know AB is the same as B minus A. So B minus A. Now you can't, now on a paper, now what you can't write in a paper is you can't write this on a paper because that's technically not correct. If you do want to write out, you have to put OB minus OA. So what you can do is you can just do it one step. AB is the same as B minus A. B is 0 minus 3, 7. I hate the IJ and K. Reason that I don't like IJ and K is because in here, you might get a mistake of not putting the 0 on the I. Because there's I missing in there. So sometimes it could be quite confusing. However, when you write a column vector, there are always 3 numbers. Minus A. So B minus A, 1, 5, minus 2. So 0 minus 1 is minus 1, minus 3 minus 5 is minus 8, 7 minus 2 is 9. That's an easy. AB equals minus 1, minus 8, 9. Okay, straightforward, nice and easy. Right, example. Now, I know vector is probably one of the biggest nightmare a lot of students would hate when they go to 6th form A-level maths, but actually, in here it's actually not too much because you've done a lot of work in year 12. Find the magnitude, example number 4, find the magnitude of A and hence find the, I don't know what it's called, I think I just call it A hat or hat of A, whatever. The unit vector in the direction of A. So first of all, find the magnitude. To find the magnitude, the symbol of magnitude is a modulus sign. Okay, the 2 bars means the magnitude of A. To find the magnitude, and remember, how do we do that? Square each number and then square root them. Okay, so square root 2 squared plus 1 squared plus 4 squared. Well, you can put a minus 1 in there if you like to, but put a bracket. I normally don't put a minus because I know minus square will give you positive anyway. So 2, 4, 4, 5, 16, root 21. Just double check. Imagine math is dangerous. Yep, root 21 is correct. Next one, A hat. Now, anyone confident enough to explain what does unit vector mean? Sorry? Vector over magnitude is correct. Okay. Now, why is that the case? Now, think about on a side note in here. If you think about what unit vector is, let's say I've got another vector. Let's put it B, 3i plus 4j. Okay, 3i plus 4j. If I have to draw it out, is 3 to the right and 4 up. That means the vector is here, right? That's the vector B. Now, what is the distance or the magnitude of B? 3, 4, 5. Yeah, so that the distance will be 3 squared plus 4 squared, square root, that will be 5. The distance of this will be 5. So what unit vector mean is, if we shrink this vector to distance of 1, so now when we say distance is just 1, the length is just 1. So essentially what you've done in here is you have multiplied by a scale factor of a theta. Right? So where the 5 come from? The 5 come from the magnitude. That's why the unit vector of B will be 3i plus 4j times a fifth. So essentially in here, you're right. So to find the unit vector, you can do the vector divided by the magnitude. So unit vector equals 1 over root 21 of the vector A, 2i minus j plus k. We're going to leave it like this. I'll be asking. You can do root 21, you can rationalize it, makes it root 21 over 21, but it doesn't really matter. So that's what unit vector means. Unit vector essentially means if you want to think about shrinking the distance back to 1. Right. So next. Right. More. Now, the reason I didn't give you any practice question in here is because I think these are something you're going to get 12. It's just adding a third dimension. Calculation-wise, the same. Now, there's something a little bit newer. So, if the vector A equal xi plus yj plus zk, so that's a 3D vector, So a 3D vector in real life is, think about a ruler, okay? A ruler in real life, that's a 3D, because a vector is a line, so a ruler is like a line in 3D, it has 3 dimensions. So we're talking about in here, if A makes an angle theta x with the positive x-axis, then cos theta equals x over the modulus of A. Similarly for angles theta y and theta z. I don't think I've seen this being asked before, but they just sneak it in the syllabus. But I don't think it has been asked before in the exam, because this is so trivial. I don't think they will ever ask you. But well, anyway, do you remember the formula? Cos theta equals x over A. So we'll see how this one do example over 5. Find the angles at the vector A, 2i minus 3j minus k mixed with each of the positive coordinate axes to one decimal place. So we'll do axis by axis. So let's do x-axis. Okay. So where's the formula? Cos theta x equal x over the modulus of A. So essentially, what the angle we're trying to find here is, if we use a 2D, sorry, I'm jumping back and forth. But if we think about in 2D, just in 2D, okay, we've got x and y axis in here. Okay, here's the line. Here's the line, okay, the vector A. Now, if it's a 2D sense, the theta x we're measuring is the line, the vector, making with the x-axis. So this will be a theta x in 2D sense. And theta y will be the vector, the angle, the vector making with the y-axis. This one, essentially. Okay. And for 3D, there'll be a theta z because there will be a third axis in the 3D. So theta x means the angle between the vector and the x-axis. Right. So anyway, but this is the formula. Cos theta x equal x over modulus of A. So in here, we do have to find the modulus of A first. On the side note here, modulus of A, or the magnitude of A, equal 2 squared plus 3 squared plus 1 squared, 4, 9, 13, root 14. So cos theta x equal x, which is, so if you think about this is x, this is y, and that's z. X is 2, so 2 over root 14. The x value of the vector, 2 over root 14. And if you do arc cos or inverse cos, you get 57.7 degree in 1 decimal place. So that's for x-axis, that's your y-axis. So y-axis, cos theta y equals y over magnitude of A. So theta y equals to cos of the y value, which is -3. So if we look on the x, if we look at the axis vector of A, y is -3j. So -3 on the y, magnitude of A doesn't change, √14. Just plug it in a calculator, you will get 143.3 degrees. Now you might want to pause video, have a go at Z axis, and then when you're ready for the answer, you can press play. The angle for the Z axis, cos theta Z equals Z over modulus of A. The value of Z is -1 because minus K is in the vector minus K. Therefore, -1 over √14, 105.5 degrees. Right? And that's it for 12.1 and 12.2.